Okay, I have the protein ENaC, which is epithelial sodium channel, and the mutation was cysteine 479 is replaced by arginine. The purpose of ENaC is to transport sodium across membranes where it lives. They move down a gradient. As you see, I have a gradient going down into the cell interior, and it's made by Na plus or K plus ATPase, and it's located in the membranes of epithelial cells. It's a relay molecule because it moves down a gradient over and over, which allows people to regulate their blood pressure and other cells that require sodium. It's located in the apical membrane, which is in the nephron of epithelial cells. You have sodium in the distal kidney tubules, lung, respiratory tracts, male and female reproductive tracts, sweat and saliva glands, placenta, and the colon. It basically happens in all of living things. Usually when you have a mutation of ENaC, you start to see it at a young age. Becomes more active because it produces more sodium with no change in density. Over here I have a mutated ENaC produce, which basically what happens in the mutation is all of the ENaC basically sits at the surface, and there's not enough gradient to move it down into the cell interior. So the ends of the ENaC channel cannot connect to the NED4, which basically causes all the sodium to sit up top, and therefore it causes the sodium to bunch up, and basically that's what causes people to get high blood pressure. Basically, it allows the protein to produce a surplus of sodium without a blocker to stop it. Then the beta gene, which is the B, it might be extremely short. As you see, any of these strands at the end can be extremely short, which doesn't allow it to move down the gradient as easily as it would in the original ENaC cell. As you see, these ones are super long, and they connect to the NED4, which connect to the interior, which helps it move down a gradient a lot easier, a lot faster, and to help regulate blood pressure as well. Then the limitations that the model doesn't show is aldosterone. Aldosterone is a very unique part of the cell. Unfortunately, I couldn't find a ENaC cell that had aldosterone connected in it without me being able. I would have to draw. I wouldn't be able to make a 3D model of the cell that was shown to me. So it basically doesn't show with the aldosterone. It shows the entire process that the protein takes through the body, but due to that, I wasn't able to show it. That's pretty much the only limitation that is on the mutation. But yeah, so sodium in this one, as you can see, a lot of the sodium is bunched up here, and there's no sodium down here. That's because the ends of the channels can't connect to the NED4, which NED4 helps move the sodium through the body even more quickly and efficiently. On this one, as you see, there's sodium up here, but there's not a lot, and there's a sodium down here. That helps, the gradient moves down. These are connected to the NED4, which helps it move down even better. The Na plus K plus ATPase also helps put 3 sodium and 2 potassium molecules. That's how they move through the permeable membrane. And then yeah, that's basically it. This is the mutated model, and this is the regular ENaC model. As you see, there's not much difference, but when you look closely, the ends are not connected to the NED4, and there's no sodium at the bottom because all of it's bunched up. There's no surface density for the protein to change and move down molecules into the cell interior, from the lumen into the cell interior.